All right. Correlation and linear regression. Correlation. Anybody ever heard that term before? Correlation. Y'all heard of that before? Okay. So who remembers? You've had a little exposure, I know, to this chapter in your linear algebra classes. What is the formula for a line? Who remembers that one?
Y equals mx plus b.
Yeah, y'all remember that? Y equals mx plus b? Okay, so if you understand that idea, we're talking what? Rise over run? Rise over run, remember that? If you understand that idea, you'll get correlation, okay, and regression as well, all right? But what we're going to do is put it into a business context, actually plug some meaningful data into it, and look at some real-world applications, okay? Not just looking at a line, but being able to plug some real-world data in and make a decision off that line, okay? Because that's what we're doing in our stats, isn't it? Remember, all the way back from day one, that's what we're doing here. We're doing all this to learn how to make better business decisions, all right? Okay, so what is correlation analysis? It's used to report the relationship, it's used to measure, group of techniques used to measure the relationship between two variables. Okay, so what have we seen an instance where we've looked at two variables already in this class? Do you remember what the specifics of that circumstance were? Y'all remember that? When have we looked at two variables together at the same time before? Do you remember these right here? Where it would start like that, and then go like that, and then have another node there, and boom, 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 boom. Remember those? You remember what those were called? The decision trees, right? Isn't that what we called them in here? That's one word for them.
Something like that.
It's some kind of tree, analysis tree. I can't remember. It's a tree, right? I think decision tree. That's what I've always called it. And I think they did have a different term, but I don't remember. But anyway, because it helps you make a decision, right? It helps you, we assign probabilities to each one, and it helps us decide which course of action to take, right? Or which one's more likely. Okay, and do you remember how we also laid those out before then? Do you remember those contingency tables? Yeah? Like, do you remember that one where we had number of movies seen, and we had male and female? Remember that? Y'all remember doing that? And we applied all the different rules of addition and multiplication to it. So we have looked at two different variables before, haven't we? Yeah, but we didn't really look at a relationship between the two, did we? We just kind of grouped them and walled them off, didn't we? But now we are going to be able to, we're going to have the tools to be able to say, okay, are these variables related? If so, how strongly are they related, and in what way? And I'd say in what direction are they related, okay? And we'll get to that in just a second when I'm talking about that, okay? Is that recording? Okay. Now, all right. So correlation analysis. We're looking at two different variables and seeing how they relate. Correlate, co-relate, co. We break the words down, don't we? Co is like what? And relate is what? How they intertwine. Makes sense, doesn't it? How they correlate. Okay. So right here it says, in addition to graphing, we're also going to assign a number to the sucker to describe the relationship between the variables. Okay? So we got one specific way today we're going to look at graphing these relationships. Okay? But a lot of times what? When you draw things out graphically, like in a picture, it can be sort of subjective, can it? For instance, let me ask you this. Is this line steep or not? Is that line steep? You think it is? Do you think it's steep?
Yeah.
Kinda. Do you think it's steep? Well, what about this one? Is that steep?
Not as much.
Not as steep.
But it's completely subjective, isn't it? Let me ask you about this. What is that number?
189.
What do you see? We all know what that is. It's completely objective, isn't it? There's no arguing over that, is there? Okay, so we're going to graph these out so you can kind of get a big picture of what's going on, but we're also going to have a nice little clean formula so that we know exactly what's going on, okay? All right. So let's look at these examples of problems with two variables. The amount health tech spends per month on training at Salesforce affect its monthly sales. What are my two variables in there? Does the amount health techs, this company health techs, they spend money on training their employees every month, or their Salesforce every month, does it affect the monthly sales? What are my two variables there? What are the two things I'm wondering about in there? My two factors that I can change in there. This one factor will change the other.
Amount spent on training versus, or to your monthly sales.
What'd you say? What was the first one?
Your amount spent on training.
Very good. Does everybody see that? So the amount spent on training and our monthly sales. Those can both go up or down, can't they? Are those things dependent upon each other? Or maybe is one dependent upon the other?
Yeah, because if you got bad training, you're not gonna sell anything.
Very good. So what's dependent upon what?
So the sales are dependent upon the training.
Very good. At least that's what we would think. We don't really have any numbers to back that up, do we? So again,
You have to prove it.
we got a line, what we think it might look like or something, right? But it's kind of subjective. Even if we had the numbers, it probably would be. But if we had those numbers, we could plug them in and we could know exactly, couldn't we? Okay? Both are valuable ways to look at this data. Okay? It's just that one's more precise than the other. But we could, if we had the numbers, we could chart that out, couldn't we, in some way, which I'll show you in just a minute. Here's another one. Does the number, oh, here's one y'all ought to know. Does the number of hours students study for an exam influence the exam score?
Nah.
It doesn't at all, huh? Because you would expect it to be what? The more what? The more students study, the higher their exam. But y'all studied so much for this exam and didn't do well. So obviously that doesn't hold true, huh?
That's how I passed this test before you right there.
Yeah, you studied for a whole month straight.
And
And you still bombed it. I mean, what? Not everybody.
We rejected the null
Just-
hypothesis.
The vast majority. All right. Okay, so the way we're going to graph these things out is called a scatter diagram. All right? So, like I said, we're going to draw out the picture. We're going to end up with a line, right? And we're also going to end up with that number. So first off, we're going to draw them out with these scatter plots, okay? Now we're talking about two variables, aren't we? Let's look at this information right here. So we have the name of the sales rep, and what's that second column right there? The first variable.
Sales calls.
That's the number of sales calls that they've made in the month. And what's the second variable?
Copier sold.
Copier sold. So what's going on here? We got a bunch of copier salespeople, and they're calling customers, aren't they? And here's listed the number of calls and the number of copiers sold. Do you think one might be dependent upon the other? Just what would you think?
Yeah.
Which?
I'd say your copier sold depends on your sales calls.
I would say so, wouldn't you? The more sales calls you make, maybe the more copiers you'll sell. Wouldn't you think that could be the case? Well, we got the numbers here. We could prove whether it is or not, couldn't we? So the first thing we're going to do is draw this thing out graphically. But let's look at this first. What does that say, the independent variable thing? So which would be the independent variable?
Calls.
Why would that be?
Because, well, you know how many calls you're gonna make.
Right, and does the number of sales depend upon the number of calls? Okay, so if we have our typical X and Y axis here, right? Y axis, and we have an X axis. Our X axis represents the independent variable, okay? Or at least the data is going to go on the X, the independent variable data is going to go on the X axis, okay? The Y axis is the dependent data, okay? So again, in this case, which is the independent? The number of calls they make. Because the number of copiers sold depends on the number of calls they make. So where would the number of copiers sold go?
On your one.
On the Y, right here, wouldn't it? And the number of sales calls would go here, wouldn't it? Now, let's look at Brian Verrast right here at the top. How many sales calls did he make?
96.
He made 96 sales calls. Let's say this is 100 right here. So he's about right here somewhere, isn't he? How many copiers did he sell? 41. So let's say this is 10, 20, 30, 40. right here, so he sold like 41, didn't he? Or he did sell 41. So where, if I were going to make a scatter plot, does everybody know what a scatter plot is? What they look like at least? Bunch of dots everywhere, yeah? So, if I were to plot the point where his meet, where Brian Burrows sits on this scatter plot, where would he be?
Go up and over.
We'd go up at, what, 90, what is it, 6?
96.
And we'd stop up here at where? 41, wouldn't we? And there's Brian Burrows' dot, isn't it? Okay? Now, I can tell you right now, because I've already looked at the slides, there are 15 salespeople there, okay? So how many dots are we going to end up with all over this thing?
15.
15, aren't we? Does everybody get this? Get the picture here, what we call scatter plot? Everybody understand what that is? Man, my brains are fried today. I cannot get my words out. All right. I'm camera shy, that's what it is.
One thing I know is Carlos Ramirez deserves a raise.
I know. Did y'all see that Carlos Ramirez right there? How many sales calls did he make? And how many copiers did he sell?
40 flipping one.
So he sold more copiers than he made calls. So what do you think's going on with Carlos Ramirez?
You got a 2-for-1 in there somewhere.
Well, he did.
I feel so he's making that money, or
But-
he's very persuasive
Right. But what? How would that be though?
because he's trained.
Well, yeah, he's probably been around for a long time, hasn't he?
Probably.
Take
'Cause-
one.
Huh?
But he bought.
He bought one for himself to boost his numbers.
He's like, "What's this?"
Well, no, he's probably been there for a long time, right? If I had to guess, because sales is a good gig to get into, because you build your book, don't you? And after a while, you got people calling you. You don't even have to make any calls. You go do whatever you want all day, and they just call you and say, "Hey, I need so and so. I need 2 more copiers, Carlos." Okay, no problem. Right? Pretty cool, huh? Or he's just a great salesman. Who knows?
Yep. Either way,
Either way.
he works.
Yeah. So, anyways, but does everybody understand? If I asked you right now, would you? In fact, let's do that. Where would Carlos Ramirez sit on this chart? Let's plot him in red right here. So how many? What's the dependent variable?
Wow.
The y. What's the independent variable?
Your sales cost
X. Sales calls, right? How many sales calls did he make?
40.
40. So if that's 100, 40 would be like right here, wouldn't it?
Yeah.
Now, how many copiers did he sell?
41 again.
41. Where does that go? What is this right here? My Y is my what? Dependent variable. And what is it?
Your copier sold.
Copier sold. Came right. Okay. And how many did he sell?
41.
41. Like, oh, same amount, right? So where are we going to graph Carlos Ramirez on here? We go up here at 40, don't we? And we stop at 41, don't we? Boom, and there's Carlos Ramirez. Everybody good with that? So y'all know, y'all can plot. Y'all can make a scatter plot if I asked you to, right? Fortunately, though, we're going to have Excel for that, okay? So this is going to be an extremely Excel-heavy chapter, okay? We're not going to get to it today, though. I just want to get through the basics today, and then you can work on all that stuff over the weekend, and then we'll get to it on Tuesday, all right? Okay. And I'll show you why it's going to be an Excel-heavy chapter. First off, this is something you really need to learn to do in Excel, because you really need to do this in your working career. Secondly, the graphs are a lot easier to do. They're a lot more squared off and clean when you build them in Excel. And third, I'm going to show you how we figure out the number side of this thing, and it's a pretty nasty formula, so we'd rather just have Excel do it, okay? But we still got to learn the basics, what's behind it, right? So let's look at this problem right here. This is what we just plotted out, okay? This is what it looks like if we actually did it, if we were building on Excel, or even by hand with graph paper or something, but we're not going that far. Again, we're going to do it in Excel. North American Copier sells copiers to businesses of all sizes through the U.S. and Canada. The National Sales Manager is preparing for an upcoming sales meeting and would like to impress upon the sales reps the importance of making an extra sales call every day. She takes a random sample of 15 sales reps, and that's the data we just saw, right? This is the random sample of 15 sales reps. And gathers information on the number of sales calls made last month and the number of copiers sold. Develop a scatter diagram of the data. So this is what it would look like. What we just built there, this is what it actually looks like. So where is, what's his name? Verast, where's he at? 96 and 41, right? So where's his dot? Where's 96? And let's go up to 41, which would be like right here, right? Where would Carlos Ramirez be? He had 40 sales calls. And how many did he sell? 41. So that's Carlos Ramirez right there, isn't it? Everybody see that? Okay. We good? Scatter plots, yeah? But let me ask you something about this. If I were to draw a line through this sucker, trying to touch as many of the dots as I could, what would it look like? Would it look like this?
Yep.
Or would it look like this maybe? 2, 3, 4, 5. Or would it look like this maybe? Maybe like this? Which one?
Whichever way makes you look the best.
Well, right, again. So, what we're talking about with that line is a little bit of ambiguity, isn't it? Okay? So I'd rather have a number to tell me exactly what we're talking about here. Okay? Exactly. Give me an exact measurement of the relationship between these two variables. Because what's going on here, actually? What is really going on here? Got this manager here. She just graduated from Dalton College. She gets a job at North American Copier Sales, and she's going in to talk to all the salespeople to convince them to stay and work more, work later every day and make more calls. Oh, Carlos Ramirez has been doing this job 35 years. Does he want to hear that crap? He knows what he's doing. What does she need to do in order to convince Carlos Ramirez? Huh?
Give them evidence.
Give him evidence. Give him a scatter plot. Give him a number. Saying, look, you will make more money. This is what we're coming up with, okay? This is what's going on in our business. That's why this kind of stuff is important. You can make a case with it, okay? All this stuff we've been doing. All right, so that's the real question we're trying to answer, isn't it? If I'm telling these people to make more calls, are they going to sell? Are they going to make more sales? Right? Is it worth our time to mess with this? Okay, that's why we want to figure out the strength between these two variables and the direction. Okay. So the correlation coefficient, that's going to give us that number. Okay? That's going to give us the hard, irrefutable number that everybody looks at and sees the same thing. Okay? Now, what is a coefficient? Who remembers? Anybody? Coefficient. So a coefficient is,
What goes with your variable to modify it?
well, no, it's more like a formula that sets a group of numbers within a range, okay? Sets a group of criteria within a certain parameter. Who remembers the coefficient of skewness that we did? Y'all remember doing that in like might have been chapter 3 or something?
3 or 4.
Yeah, landed between, so you plug remember skewness, whether it was skewed over, the curve was skewed over this way or skewed over that way, remember? And we could measure that with that coefficient of skewness, how skewed it was. But remember, it landed between -3 and 3, didn't it? Always, every time. That's because we set all that number back to itself, didn't we? You remember what I'm talking about? The coefficient of skewness. Yeah? Same thing here. A coefficient puts it into a scale, doesn't it? A coefficient's like a scale. A formula that puts a bunch of numbers into a scale. Okay? So, in this case, this correlation coefficient is going to give us an answer between -1 and 1. Okay? So if you do this formula that we're about to look at, and you get an answer outside of 1 and -1, it's wrong. Everybody understand that? Okay, between -1 and 1. And it's going to tell us how strong and which way that relationship goes. Okay? When I say which way, I'll show you what I'm talking about in just a minute. Okay? But the strength and the direction of the relationship. Okay? So it ranges from -1 to 1. if you get an answer at 0, that means there's no relationship between those two variables. So -1 means there is a relationship, doesn't it? It doesn't mean there's no relationship. 0 means there's no relationship. Okay? We'll get to that in just a second. Jumping the gun a little bit. So a value near, let's go to this next slide. So a value near 1, when we plug all our numbers, those variables, right, into this formula, we get that answer between -1 and 1, right? If it's over here towards +1, we're looking at perfect positive correlation. Meaning for every movement that the independent variable makes, the dependent variable makes a corresponding movement, okay? Of the same degree. Who remembers the old formula rise over run? Remember all that? Well, let me ask you something. If you put a negative rise over a positive run, what number do you get? You get a negative number, don't you? So what are we talking about here? What would our rise be here? Positive or negative?
Positive.
Positive. And what would our run be?
Positive.
Positive. Right here, what would our rise be?
Negative.
And what would our run be?
Positive.
If you put a negative over a positive, what do you get?
Negative.
You get a negative. Okay, so if our number's heading, if our line, when we draw that scatter plot, if our line is heading like this, I should have drawn it over there for the down video. But if our line is heading down like this, are we going to get a positive number or a negative number?
Negative.
Negative number, aren't we? If our line is heading up to the northeast like this, what are we going to get, a positive number or a negative number?
Positive.
Positive. Okay, so when we draw that scatter plot and we got a line heading like this, we're going to get a positive number, positive correlation over here, aren't we? Because all that line is a bunch of dots where our two variables meet, isn't it? Okay? So if it's trending that way, we know we're going positive. If it's trending down, we know we're going negative, don't we? Okay? Now, if we're going 1 for 1, and we're right over here at 1.0, what do we call that relationship? Perfectly what? Positive. Right? Same thing over here. If we're trending at 1 to 1, at -1, rise 1, run 1, rise -1, run 1, and we get this perfect -1 correlation, what is our, what would the number be? If it's perfect, -1, right? But what if there's no correlation? It's 0, isn't it? So -1 does not mean there's no correlation. It just means it's a strong negative correlation. They are correlated, but they're going down like this, right? Okay. And positive ones mean, yeah, they're correlated, they're going up. 0 is where there's no correlation. It's going to look like that, isn't it? Not like that, but like this, isn't it? And why is that? What's my rise? 0. Over what? Doesn't matter, it's 0. See what I'm saying? No correlation. All right. Does everybody understand what we're talking about here? Okay, this is just the scale that we're going to put it on. We're going to get a number when we plug it into the formula between here and here. And wherever it falls in the scale tells us about the relationship. So for instance, if we get something around this 0.5 right here, we got a moderately positive correlation, don't we? Everybody understand what I'm saying? Okay. And so it would be a line not perfect 45 degrees like that, but it would be more, it would be half of that, really, wouldn't it, if it's 0.5? Everybody see what I'm saying? Moderately positive. Okay. So let's look at what we're talking about right here. Let's start with this one. What is our independent variable right here?
Price.
And what is our dependent variable? Quantity. And if I were to draw one line to touch as many of those dots as I could, what would it look like?
It'd be downward slope.
It'd be looking like that, wouldn't it? Everybody see that? So this is a what kind of relationship?
Negative.
Negative relationship. It tells us, we don't have the numbers to measure it, but it tells us what? That it's strong or weak.
Weak.
So if it's a weak negative correlation, where are we here?
Somewhere between 0.5 and 0.
Somewhere over here, isn't it? That's about where we're following. -0 to -0.5 somewhere. Everybody see that? Okay. What is this called, by the way? When our price is heading down like this and the quantity demanded is heading, or price is heading up and the quantity demanded is heading down. What is this called? And it can move like shift, remember? It can shift. The demand curve. This is the demand curve, isn't it? Remember in the supply curve like this, because the more expensive things get, the more suppliers you're going to get into the market, the more money they can make, right? Remember supply curve, demand curve? You are ready for your test. All right.
Basically, the way it works is for a positive correlation, as your X increases, your Y increases, and then for a negative, as your X increases, your Y decreases.
Right, exactly. So that's why you get,
So your dependent value, depending on whether it rises or runs, as your independent rises, gives you your correlations.
yeah, exactly. So see, if we're heading this way and my line's heading down that way, what happens with my rise? It's negative, but my run's still positive, isn't it? So negative over positive can give you negative, isn't it?
Yep.
Is that what you're saying?
Yeah.
Yeah.
I was just clarifying it for the camera.
Oh. Hey, this is my tryout, dude. You get your own audition. I don't watch that movie.
Oh, yeah. Anyways, carry on.
All right. Do you want to squat for the camera then? I want to see that, dude. You got to come in. That should have been your Halloween, man.
I wore that for
For what?
for a party.
Did you? That's
Yeah.
pretty funny.
So, yeah, it's great. Anywho,
All right, so what is this one? What are we looking at? What's our independent variable? Hours. Oh, this is the one we looked at before, isn't it? And what's our dependent variable? Your score. So if we were to draw a line that looks, that touches as many of these dots as possible, what would it look like? In most cases. In our case, what would it look like? Because y'all studied so much, right? You put in so many hours, but your grades went down. Crazy. Okay. All right, so everybody see the strong positive. It's strongly positive. Where are we at here? Where are we at in this range? We're way over here, aren't we? Wow, maybe we should have done this slide first thing at the very beginning of the semester. Huh?
I think we did last time. But I remember all this.
But I'll pay for that tattoo.
Okay.
How about that one?
I got that tattoo.
You do?
I did back in school. It was all over my face. It just went that way. Dot, 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 dot.
Oh, you did not.
A little bit for a while. It's bad.
You had it removed. What are you talking about?
I had a bunch of little acne spots and stuff. And
Oh,
a bunch of dots.
that. I thought you meant you
No,
had
I
a face
didn't have
tat.
a
And I was like,
tattoo.
please no.
No, it's-
What is this trend with all y'all's rappers and everything? Getting these face tattoos.
They're not my rappers.
What are y'all thinking, man? I don't understand this generation. Face tattoos have never been cool.
I'm
Ever.
less.
That's what happens
Till
when you
now.
eat Tide Pods.
Huh?
That's what happens when you eat Tide Pods. You think it's a good idea.
Tide Pods.
Here we go. Anyways, let's talk about the statistics of Tide Pod eating.
Yeah.
Go ahead. Number of
All right,
children.
what about this? This one's kind of counterintuitive to me, or at least it's non-intuitive. So,
Okay.
what's the relationship here? Where would that line be if I were to touch as many of these dots as possible? It's all over the place, isn't it? Is there a relationship here?
Nah.
Where is this one going to fall on our scale?
Zero.
Zero. It's not going to fall over here. No relationship is going to fall right here at zero, isn't it? It's not going to fall in negative. That's negative. That's positive. This is just a flat line somewhere, isn't it? And it's right here in the middle, okay? Now, number of children and income. That's interesting to me, huh? There's no relationship between number of children and income. Which I guess that's true. Some people, what? Make a lot of money and have no children. Some people make a lot of money and have a lot of kids. It almost seems like that could be the independent variable too, huh? And number of children could be the dependent variable. So it makes sense that that's kind of all over the place, doesn't it? Yeah? Okay, so are we good with this? And how we read
I'm just
this chart?
I'm just confused as to how you could have negative one number of children.
I know, but that's, if you notice though, there's none over there. You know what I mean? But I noticed that too. It's like,
It's
it
like
does start at zero, thank goodness.
you see one dot at negative one, you're like,
I know.
oof.
That'd be funny. I don't want to know about that. Well, if you had negative one child, your income would be probably really high. Why is that?
Probably sold it.
You sold your kid? No, I'm just kidding.
So you gave up your firstborn to play the fiddle.
And your income really boosted that year. All right.
Anywho.
So, let's skip this slide and let's go to this next one. Uh-oh. Oh no. We got a problem, y'all.
The correlation coefficient.
Well, no, the problem is I wanted to stop at slide 10 and we're already at slide 9.
Hey,
Uh-oh.
see 50 degrees, still.
Huh? Now y'all are awake. Everybody woke up. Look at that.
Well, it's because it's 5:34, and I'm really looking forward to finishing slides 9 and 10.
Out of 534 out of 6?
Yeah.
Oh, it's already 6. No, it's 12:30.
Yeah. I know.
All right. We got plenty of time.
Do we now?
All right, so the correlation coefficient, that's what we were just talking about, right? Well, here's the infamous formula. And hopefully by looking at it, if you look at it for just a minute, you can see why we're going to do it in Excel, because it's nasty, isn't it? What are we looking at here? So we already know that that R is going to come out, what we're solving for, it's going to come out between -1 and 1, isn't it? Yeah? What do we plug in for this big uppercase sigma right here? Nothing, ever. Remember, that's an operator. It tells us to add all this stuff up. Remember that? Okay. What's X?
X is.
Well, no. X bar is our mean, isn't it?
Yeah.
What is the X?
Whatever value you're looking at.
It's whatever value. It's our independent variable. So in this case, here's that chart. Don't look at this part yet. Here's the chart that we've been looking at with Carlos and Ryan and Carlos and them. Sales calls and copiers sold. What's our X? Sales calls, isn't it? So in this case, it's 96. What's our X bar? It's all of these averaged, isn't it? What would be our Y, our first Y? It would be that, wouldn't it? And what would our Y bar be? All that. So what would our X minus X bar be? Well, in this case, it's 0, because it averages to 96. It must average. These must average to 96. 96 minus 96 is 0, isn't it? Okay. And copiers sold is 41 minus 4, so that must average to what? 45, yeah? Everybody see what I'm saying? Because it's 41 minus 45 is minus 4. So that's that, and then we multiply them together in this step, don't we? And add it all up right here, don't we? Does this look familiar, this process? Not exactly like this, but this. Y'all remember making a big table like this somewhere?
It's close to finding your standard dev.
Yeah, remember doing that? If you do standard deviation out by hand, it's that big old long table like that, remember? X bar, X minus X bar squared, or X minus X bar squared, and then add it all up. Remember, it's the same thing. Glad you didn't forget that, because let's look at our denominator in that problem. What do we have going on?
N minus 1, sample size minus 1.
N minus 1 times what? What's the lowercase s? Standard deviation of the sample. Very good. Of x. So it's the standard deviation of all these times the standard deviation of all these. But again, we just said that, if you're doing this by hand, you got another big table of standard deviation. You got to do it twice, don't you? Okay? So to do that problem, you do one of those, and then you do 2 more with doing the standard deviations, big tables, don't you? And this is a sample size of what? 15. Imagine you had a sample size of 1,500. That would take a little while, wouldn't it? That's why we're going to do this in Excel. All right? By the way, I didn't do Excel for the last test because I started to make a video, and it was more, first off, it takes longer to do it in Excel than it does just by hand. And I was confusing myself with the video. I was having to stop it and start back and say, I got to explain this. It would have confused the hell out of everybody, so it's just easier to do it by hand, okay? But we're going to look at some stuff at the very end here where maybe it'll give you some shortcuts. But we're not done with hypothesis testing, by the way. We've got some more in this chapter, actually, okay? All right, so with this data set that we've been looking at, what is our R? What does it come out to? Got it right here. So again, we did all that. The numerator adds up to 6672. Then we put it over what? N minus 1 times the 2 standard deviations. Is that answer between negative 1 and 1?
Yes.
It is. That's where you thought it would fall, isn't it? What about that X bar and that Y bar? Where did we say we got that from?
Your means of your sales goals and copier.
Yeah, very good. The means of our independent and dependent variables, right? This X bar in the top and this Y bar in the top. Let's look at this right here, why that's important. This is actually setting it up for something I want to talk about later, but let's look at what we can do here. So the average of all the independent variables is what? 96, isn't it? So we got a line right here, don't we? And the average of all our dependent variables is what?
45.
45, so we got a line coming through here, don't we? Now let me ask you something. We know where each of these dots are, don't we? We know that Brian Verast is like right, he's right on the average, isn't he? Remember it was 0 when we took the X minus X bar? And he sold 41 copiers. So we know that's Brian Verast, and we remember that that's Carlos, right? What was his name? Yeah, Carlos Ramirez was right there, remember? So let's look at Carlos, for instance. Do we know what the difference is between these two? Between the average and the dot? We do, don't we? We saw it on that last chart, don't we? And we also know what this average is, don't we? The distance here. I'm just pointing that out to show you that on the scatter plot we do have actuals, don't we? Okay, we will be using that a little bit later in the line of least squares and stuff like that, okay? It's just something we're going to study later. But in regression, we're doing regression this chapter, okay? Now, okay, so everybody feel good about this? Does everybody feel like, well, not yet, because again, let's just focus on getting our supplemental done this weekend, okay? And we'll look at the Excel on Tuesday. But it's just really just one formula. It's really not hard at all. But it's also, there's a couple ways to do it, which I'll probably be pretty mad when I show you the really, really easy way to do it. But anyway, we got one more slide. Let's do it. Okay. Oh, but again, how would you characterize that relationship right there?
Strong positive.
Just strongly positive, isn't it? Now, looking at that line right there, looking at this thing right here, where would we draw that line in the scatter plot? Like that, wouldn't we? And it looks pretty strongly positive, doesn't it? Everybody see that? And sure enough, we know it's strongly positive now, don't we? Look at that number. There's not much to argue about with that, is there? Okay. So yeah, by the way, she could do what? She could be like, let's make some extra phone calls and make some more money, right? Okay, and she'd have an argument, wouldn't she? Who remembers the Applewood Auto Group?
Oh, here, we bring it back.
Full circle. Everybody remember Applewood? How many cars did Applewood Auto Group sell last month?
So that's
180, remember that? There's 180 different data points that represented the profit margins, right? What other data did we have? We had the number of cars they sold, that we had the profit for each sale. We had the age of the buyer. Remember that in that data I sent you that we worked on the Excel on? We had the type of car it was. Remember there were like 5 different types: truck, SUV, car, blah blah, sedan, whatever. And we had dealership. Remember that? We had Tianesta, Sheffield, Olean, and Kane. Remember?
Okay.
Y'all remember that? Okay, so we had all that data, didn't we? So let's look at this problem right here. What is this problem asking us? Applewood Auto Group Marketing Department believes younger buyers purchase vehicles on which lower profits are earned. So Applewood Auto Group believes that our younger buyers don't buy vehicles that are as profitable for us as older buyers do. The cars we're selling to older buyers, we make more profit on. That's what we believe, at least. And why would that make sense?
Because these young folks are trying to bid with you, or trying to get cheaper cars that you don't get as much return on.
Well, right. And why is that though in general? Because older people have more money, don't they? They've been working for a while. They have another car. They have all kinds of stuff, credit histories, all that kind of stuff, don't they? So they're probably buying more expensive cars, aren't they? Okay, so we would naturally think, it wouldn't be a leap to naturally think that we're making more money off the older customers, right? So, we're thinking that we want to run an advertising campaign to attract more older customers. Sounds reasonable, right? If we're making more money off older customers, why would we not try to attract more older customers? So, before we jump into this and spend this $250 advertising on Channel 3, we are gonna build a scatter plot and a correlation coefficient to see if we need to run this ad campaign or not. Okay? How's that sound?
Good idea.
So we get into Excel, we make the scatter plot, pops out something that looks like that. If I were to draw a line, what would it look like? To hit as many of those dots as possible, what would it look like? Like this?
It'd be.
Or maybe like this? Or what about like that?
It'd be slightly positive because you're gonna catch more going up that way, but you
You say slightly, maybe like that?
yeah,
Slightly positive?
you catch a lot that way, but that's about it though.
Do y'all see any relationship? Who sees no relationship at all? Who just sees a smattering of dots all over the place? So you see a little positive. Who sees a little bit of a positive relationship? 1, 2. Y'all see a little bit of a positive. See a little bit of a positive.
Because you can kind of see where they're clustered, where they're a little bit stronger. It just kind of want to cluster that way.
Yeah, but you could also like that. You mean?
It looks kind of like.
Well, what if you read the line like that instead of that?
Yeah.
No, don't do that, y'all. If the line is heading like this, that's the direction of the line. It's always coming top, bottom to top. Okay. Don't be like, well, wait, is it heading back down that way? We're going northeast or we're going northwest. Everybody understand that? Okay, I mean, that is an important distinction to make. Don't let, I think people get confused in economics because they think like that, you know? So, the line's either like that, or like that, okay? We got 3 lines. Got me? And they're always going north, all right? So, but again, this is something that we can argue about, isn't it? Because we drew the scatter plot, but it's a little objective, isn't it? So what are we going to do here?
You're going to find your number.
We're going to use that formula and find the number that nobody's going to be arguing about, okay? And what is that going to be? Well, in this case, they plugged it into Excel, and we're going to get stuff that looks like this. And what is that answer there?
0.262.
0.262. Is that between our -1 and 1? It is, isn't it? So is that a positive relationship or negative relationship?
Well, it's positive.
How do you know it's positive?
Because it's not negative.
Because there's no negative sign in front of it, right? So which way is it heading? Like that or like that?
Right.
What's that?
Oh wait, I said always heading north, didn't I?
Always head east.
East, that's what I meant. Always heading east.
Either southeast, northeast, or
Yeah,
east.
everybody see what I'm saying here? We're always going that way, like we read, okay? Sorry, I confuse myself sometimes. All right. I'll have to edit that out. I just caught myself. I don't know why.
That'll be a
You're
blooper.
gonna be
Put that on the
doing
blooper
that.
reel.
No, I confused that. All right, guys, we got to start this class over. Take 2. Ready? Just kidding.
All right, in that case.
All right.
Good one.
But is it strong or is it weak?
Very weak.
Pretty weak, isn't it?
Yeah.
Yeah, 0.2.
It's not weak.
That's way over here next to 0.5 because the max we can have is 1, isn't it? But we're all the way down here at 0.2. Now, are we going to spend that $250 over at Channel 3? We're not even going to waste the time, are we? And why is that? What's the real answer? Are we making more money off the old geezers?
Not that much.
No. So what are we going to do? We're going to start a Social Security scam where we email. Just kidding.
Oh,
Just
yeah.
kidding.
That's a
Just
much
kidding.
better idea. I like that idea.
Definitely editing that out. All right.
There's some ideas I've heard. So, yeah.
So we're going to stop there for the day because it's a whole new ball game
Cool. I'm going to go and.
called like this kind of stuff. Remember this? Testing the significance. Didn't we just fail a test over this?
I'm going to go cry a little bit, I think.
All right, so this is where we'll pick up on Tuesday. All right, good luck on y'all's test. See ya.
thank you. So what was the amount of announcement that I missed?
Oh, nothing. I was just pissed off at y'all for failing